Hi folks, this is a two-body problem, meaning there are two objects that they are connected together and they're going to share some data. So here's what's going on. A block of mass 10 kilograms is sitting on a flat table. The coefficient of friction between the table and the block is 0.4. The block is attached to another mass of 6 kilograms via a very thin string, meaning we don't have to worry about the mass of the string. The cord is suspended over a frictionless pulley over the edge of a table. When the 6 kilogram mass is allowed to fall, what's going to be the acceleration of the entire system? All right, let's write down what we know. Mass 1 is 10 kilograms. Mass 2 is 6 kilograms. The coefficient of friction between mass 1 and the table is 0.4. And we want to know acceleration. Now, remember for two-body problems that if there is no slack in the string, the two objects are going to have the same acceleration, so both will accelerate at the same rate, and the tension is going to be the same at every point in the cord. So we're going to start, now that we have our drawing, we are going to start by putting all the forces on each object. So mass 1 is going to have a force of gravity on block 1 straight towards the center of the Earth. There's going to be a normal force on block 1. It's going to be pulled sideways by the tension in the string, and there is friction, so a force of friction will be backwards like that. Remember, we want to get our forces in this sort of a X and Y pattern. Those are all the forces on block 1. Block 2, there's going to be the force of gravity on block 2, and the tension in the string is upward. Now, if we've got wacky motion like this that's not just straight back and forth or up and down, we are going to call the direction of motion positive, so anything going off the table is positive, and anything that opposes that motion, we're going to call that negative. Next thing is we are going to sum the forces on each block in each dimension. So we're going to have a sum the forces up and down, left and right, and another up and down for block 1. So here goes nothing. I'm going to sum the forces on block 1 horizontally. I am going to sum the forces on block 1 vertically. And I am going to sum the forces on block 2. One more thing I want to say about block 2 before we start into the math, and that is there is no normal force because of the fact this is not supported by a surface. So you don't always have a normal force, only if something is sitting on a surface that's supporting some of its weight. So we're going to construct our equations. Summing the forces on block 1 horizontally. Tension is in the positive direction, so tension minus the force of friction, which is in the negative direction, is going to make mass 1 accelerate. And I forgot, didn't I? Some of the forces horizontally are going to make mass number 1 accelerate because we're asked to find the acceleration, so we know the whole system is accelerating. What are some of the forces on block 2 going to equal? Well, it's sitting on the table, not falling through or rising above, so this is going to equal 0. And what are the sum of the forces on block 2 going to equal? Well, that is going to make mass number 2 accelerate. Now we can create our equations. I got ahead of myself. Sum of the forces on block 1 vertically, well, normal force will be equal to the force of gravity. But the force of gravity on block 1. Sum of the forces on block 2, force of gravity 2 is in the positive direction, minus tension in the backwards direction is going to make mass number 2 accelerate. These are our equations. That's the big heart of the physics. Now we have to be able to prove to ourselves that we can do the math. I do not have a value for tension. Friction force I'm going to replace with mu times normal force. Mass 1 equals 10 kilograms, and I do not know my rate of acceleration. So I'm going to go down another layer and replace what I can. But I can't. I don't know anything else. So I'm stymied. So I'm going to go to my next column right here. Force normal is going to be the force of gravity on block 1. This will be mass 1 times the acceleration of gravity. So normal force, mass 1 is 10 kilograms. Acceleration of gravity is our old friend 9.8 meters per second squared. And force normal then is going to be 98 newtons. Now that I have normal force, I'm going to take that, put it back into that equation right there. So tension minus mu, normal force, 98 newtons, is going to equal 10 kilograms times A. Here I had an equation with 1, 2, 3, 4 unknowns. Now I've cut it down to 1, 2, 3 unknowns. Oh, wait a minute. I don't have another unknown. I know my coefficient of friction, don't I? 0.4. I was nervous. I had too many unknowns. Let's get rid of this. 0.4 times 98 newtons is going to equal, this is going to equal, this is going to be 39.2 newtons. So tension minus 39.2 newtons is 10 kilograms times A. Okay, one equation, 2 unknowns, hot dog. Now we can go over and create our second equation. So I'm going to go way over here. Actually, I'm going to do it down below, so I've got lots of room to write. Force of gravity on block 2 is going to be mass 2 times the acceleration of gravity minus tension is going to make my mass number 2 accelerate. Mass 2 is 6 kilograms. Acceleration of gravity is 9.8 meters per second squared minus tension, and mass 2 is my 6 kilograms times A. All right, let's simplify this a little bit. 6 times 9.8 is 58.8 newtons minus tension is 6 kilograms times A. I have 2 equations, 2 unknowns. I don't know tension, don't know acceleration. I'm solving for acceleration. So what am I going to do? I am going to solve one of the equations for tension and then shove it into the other. And just because, I'm going to solve the first equation for tension. So this equation, tension is going to be equal to 10 kilograms times A. When this moves to the other side, it will change sign. So it's plus 39.2 newtons. I'm then going to take all of that and put it into this equation for tension. So here's what I've got. I'm going to have 58.8 newtons minus tension. Now tension is all of that, 10 kilograms times A, plus 39.2 newtons equals 6 kilograms times A. I have to distribute this negative sign throughout all of that. So this is going to be 58.8 newtons minus 10 kilograms A minus, that negative sign gets distributed, 39.2 newtons equals 6 kilograms A. And I want to get all the like things together. So I've got newtons on this side, newtons on that side, and I have kilograms and acceleration. I want to put this on that side. So here's what happens. 58.8 minus 39.2. When I do that, I end up with 19.6 newtons on one side. On the other side, I've got 6 kilograms times A. This changes sign when it goes to the other side, plus 10 kilograms times A. So this is going to be 16 kilograms times A. And remember, I did have 3 sig figs, but I got a little lazy writing all my digits down. So acceleration will be 19.6 newtons divided by 16 kilograms, and I'm going to end up with 1.2 meters per second squared. Alrighty, there you go. See you next time.